Okay, students, so we're here and we're back with phase 2 of rotations. They're so fun. We're going to take 2 phases to do them. All right, so we're going to just start with some logic warm-up problems, get our brain in math mode, thinking about rotations, and then we're going to dive into some classic ones, all right? So suppose quadrilateral QRST is rotated 180 degrees. What quadrant will Q prime land? All right, quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right, so notice how it just says rotated 180 degrees. That means I can go either way. I can go boop or bloop. Either way, Q prime is going to land, actually to be precise, it's going to land perfectly right there. All right, so the answer is quadrant 3. All right. And here's another technique. So I was doing some rotations on paper yesterday, but just something I want to show you guys for the sake of your iPads is, let's see how this looks. All right, this might be pretty neat. If I do this, what happened? Copy, paste image. Notice how, let's see, I can rotate it like this. Ooh, look, that's pretty sweet. So if I wanted to do a 90-degree rotation, just copy and paste it. All right, this was 90 degrees counterclockwise. All right, so notice how like Q is 2 to the left, up 1. So to rotate this, I just go 2 to the left, up 1, Q prime. All right, and then R is just up 2. So I'm going to go up 2 for R prime, so on and so forth. R is 3 to the right, 1 up, so 3 to the right, 1 up, S prime, and then T was just down 4, so T prime will be just down 4. Let me make that look a little prettier. But another way, just as a quick way, you can physically copy and cut and rotate on Notability and do your rotations like that, and that was just a quick example of a 90-degree rotation. Pretty cool. All right. Anyways, identify the line of symmetry, so reflectional symmetry or rotational symmetry of each word. All right, now this right here, does this word have any reflectional symmetry? I'm gonna go with no. All right, I can't find any out. If I put a mirror here, it's not gonna look the same. The word mo. All right, so reflectional, or it says line, none, and then rotational, I'm just gonna write for rotational, is I could rotate it 180 degrees and it would look the same exact. Next over here we have a pretty cool word, radar. All right, again, reflectional, or sometimes called line, there's none. Now rotational, I'd have to rotate 100 or 360 degrees, so the rotation is none again. All right, because it rotational symmetry, remember it has to be 180 degrees or less. Which brings us into our next logic problem. Identify the error in logic below. The figure has one line of symmetry and 180 degrees rotational symmetry. All right, so clearly, let's look at the rotational symmetry. I could go bloop, just 180 degrees, and this bow tie, whatever you want to call it, would look the same exact. All right, but let's look at line symmetry. If I put a mirror here, the image would look the same. And if I put a mirror here, the image would look the same. All right, so it has 2 lines of reflectional symmetry. Whoever wrote this statement, this was probably a Davidson student that wrote this, because only a Davidson student would be so dumb, LOL. All right. In the figure, describe the rotation that moves triangle 1 to triangle 2. All right, so let's see, triangle 1 to triangle 2. How many degrees is this? Well, let's think for a second. All right, There's 1, 2, 3, 4, 5, 6, 7, 8. So there's 360 divided by 8 equals 45 degrees. All right. So that means if I move one space, that's 45 degrees, another 45 degrees, so that's a total of 90, and another 45 degrees. So what I can say is 135 degree rotation clockwise. So that's the way a clock goes. Or I can be extra, and I could say 225 degrees counterclockwise. All right, this is probably what a normal person would do, a sane person. Only a true psychopath would say 225 degrees counterclockwise. That's so far. I don't think I can even count that high. All right, so in the next video, we're going to do a gizmo. Stay tuned for more.